Hey, Vlad here, devinside.com. Welcome to another video. In case you're new here, you should probably know two things. A, this is mostly a Scala channel, however, occasionally we're covering all kinds of dev topics over here. And B, if you want to see more videos like this, you should probably not subscribe, because this video is vastly different from the rest of the content. I haven't settled on the title for this video just yet, but at least at the moment of this recording, I'm thinking of the last JSON tutorial, and I'm going to tell you why 8 seconds from now. Welcome back. Now, I have a YouTube channel and therefore I totally understand the value of video content. I understand that many people, me included, learn better with video content. Maybe they don't know where to start and maybe they don't like the scientific jargon, etc., etc. There are all kinds of reasons to prefer video content. However, topics like JSON are a huge exception, and let me tell you why. See, the specification for JSON is only, wait for it, 5 pages long. Most of these pages are filled with colorful pictures, and there is basically only one word which might require further explanation. This word is Unicode, and I made the video about it. It was the prerequisite for this video, actually. The TLDR is that Unicode is the standardized map for all the textual characters on this particular planet. Imagine my surprise when I found out that there are many JSON tutorials out there on YouTube with hundreds and thousands of views. And by the way, if after watching this you still prefer to actually watch a video instead of reading the specs, let me recommend you one. Let me open my browser, and if I type in YouTube JSON, you're going to see a bunch of tutorials, and many of them have 33,000, 394,000, 700,000. Let me recommend you one, and no, it's not mine. It's this one, JSON Crash Course by a guy by the channel called Traversy Media. It's being run by a guy called Brad Traversy. I've been his patron for over 2 years. He recently hit 1 million subscribers. It's a really good channel. So if you don't trust me, trust this 1 million other guy, 1,001,000. Now, if on the other hand, you actually go and want to check out the specs for yourself, well, let me Google it for you. Let me close this. Let me open another tab. Let me close that one. So if I just type in JSON into my my Google, in this case in Google Chrome, the first page that you find is json.org. If you click over there, let me zoom in a little bit, maybe even a little bit more. You see that there's basically the first line says introducing JSON. The second line says how JavaScript works by Douglas Rockford, who is also the inventor of JSON. This is basically just a promotion of a book, translation into different languages. And there you go. The fourth line is basically the spec. Over here you have a small summary. You can also scroll down a little bit and you see also a little bit of a summary. This is a very small landing page, and this is how you can access JSON from other language. Notice that all of this time I didn't even explain what JSON is because the specification does it for you. So what we can do is we can just open this in another tab, and it will load a PDF which is like 16 pages long, 16 over here. However, you don't need all of them, right? So if you scroll down, you actually see, the first page was empty, and this is actually the content. It goes from page 1 to the last thing starts on page 4, but it actually goes until page 5. And you can scroll down, and maybe we can do this. There is some introduction. You can read through the introduction, but we can basically skip this one because this is how papers work, right? And by the way, notice that in the beginning they start with the Roman letters. Okay, we actually need to get to the regular Latin letters. All right, there we go, and this is our first page, right? So let me actually zoom out real quick, right? And show you. Okay, so this is the first page. This is the second one, third one, fourth one, and the fifth one. And the sixth one is already empty, right? So this is all that we need to go through to understand what JSON is. All right, I will actually read it for you. All right, so scope. JSON is a lightweight text-based language-independent syntax for defining data interchange formats. It was derived from the ECMAScript, which is basically JavaScript, programming language, but is programming language independent, right? So you can use JSON from any kind of language. JSON defines a small set of structuring rules for the portable representation of structured data, right? So it's a way to structure data, transfer it between computers, all right? Blah, blah, blah. The goal is just to define the syntax. Its intent is not to provide any semantics or interpretation of text conforming to that syntax, right? This is a typical thing about JSON. JSON is just a format. It's just syntax. Once you read that JSON out, you need to understand yourself what is actually inside of it, okay? It also intentionally does not define how a valid JSON text might be internalized into the data structures of a programming language, right? So you will see vague similarities between JSON and, for example, objects in an object-oriented object-oriented language, or arrays in other languages, but the specification itself does not explain how to convert from JSON to them. All right, there are many possible semantics that could be applied to the JSON syntax and many ways that a JSON text can be processed or mapped by a programming language. That's what I just said. Meaningful interchange of information using JSON requires agreement among the involved parties on the specific semantics to be applied. So again, JSON is all about syntax. Defining specific semantic interpretations of JSON is potentially a topic for other specification. Similarly, language mappings of JSON can also be independently specified. For example, ECMA 262 defines mappings between valid JSON text and ECMAScript's runtime data structures, right? So this is one of the things that you're going to see in all the tutorials about JSON that say that basically JSON is a subset of JavaScript. Okay, we're going to talk about this actually a little bit by the end of the video. All right, a conforming JSON text is a sequence of Unicode code points. Unicode, I explained it in the previous video, that strictly conforms to the JSON grammar defined by this specification. A conforming processor or a parser of JSON text should not accept any inputs that are not conforming JSON text. A conforming processor may impose semantic restrictions, for example, that the number should be smaller than 100 or some other weird restrictions that limit the set of conforming JSON text that it will process. All right, so you got normative references, you can skip that. All right, so there we go, JSON text. This is pretty much the first page that you actually kind of need to read. A JSON text is a sequence of tokens tokens is basically characters or code points, formed from Unicode code points that conforms to the JSON value grammar. The set of tokens includes 6 structural tokens, strings, numbers, and 3 literal name tokens. And here they are. These are the 6 structural tokens. You see the graphical representation over here. And you see the Unicode code point over here. This is basically a table, right? And this is also the name of the Unicode code point. For example, the left square bracket, this is how it looks like in Unicode, and this is how you would see it in any text documents, right? So basically you have curly brackets, you have the rectangular brackets, you have the colons, and you have the commas. That's all that you have, okay? There are 3 literal name tokens, right? So you have the booleans true and false, and you have the null. This is how they're represented, right? So this is the character for T, this is the character for R, the character for U, and the character for E, right? True, false, null, okay? So for example, the last character is E, you see it over here, 6565, it's the same character, okay? Insignificant white space is allowed before or after any token, like in most programming languages. Well, actually not most programming languages. Some languages are really once white spaces are significant in some programming language, but in languages like Java, C, C#, Scala, you have like curly braces and then other kinds of brackets to denote scopes, and therefore white spaces don't really matter. JSON is one of them, right? So white spaces don't matter unless it's inside of a string, obviously. Okay, white space is any sequence of one or more of the following code points, right? So it's not just white spaces; it can also be tabulation, line feed, carriage return, which is basically a new line, and well, obviously space. Okay, white space is not allowed within any token except that space is allowed in strings. Obviously, you can have a space in a string, but yeah. All right. Now you have JSON values, right? So these are all the kinds of I'm going to call them entities, right? So these are the things that you can have inside of JSON, right? So you can have booleans, right? So you can have true and false. You can have the null. Thank God for that. You can have objects, you can have arrays, you can have numbers, and you can have strings. And if you're going to scroll down, it's going to explain how an object looks like, how an array looks like, how a number looks like, and so on. Okay. And this graphical notation basically shows you what's possible, right? So you start over here and you can choose to create an array and you end over here, right? For example, let's scroll down. We have objects, right? So this one, objects, right? An object structure is represented as a pair of curly brackets, bracket tokens, surrounding 0 or more name value pairs. This is exactly what you see over here. You have a curly brace. You can choose to go this way and end with a curly brace, and therefore you're going to have an empty object. Or you can go over here, you can curly brace, and then you can go into a string, right? We're going to see down below how a string looks like. Then you can have a column. You can have some value. It could be a string, but it could be an integer. It could be a null. It could be true. It could be a false. And then you have another curly brackets, right? And then you might have another comma and have another key value pair, right? So an object is a bunch of key value pairs. All right. So a name is a string, right? So it has to be a string. This is different to ECMAScript or to JavaScript. It has to be a string, and therefore we're going to see later that it means that it needs to be surrounded with double quotes, not a single quotes, double quotes. But we're going to get to that. This is the spec. Okay. A name is a string. A single colon token follows each name. This one, separating the name from the value. This one, a single comma token separates a value from a following name, right? So you can have a comma and then you can have another key value pair or string value pair. The JSON syntax does not impose any restrictions on the strings used as names, right? So, like in a typical programming language, for example, you might not use a space, for example, inside of an identifier, or you might like in Java, for example, you might not start the name of your identifier with a digit, right? So it always has to be a letter, things like this. Okay, but in JSON it doesn't matter. It's regular strings. You can have whatever you want inside of these strings. Okay, so again, the JSON syntax does not impose any restrictions on the strings used as names. Does not require that names strings be unique, right? So it's not like a map in a traditional programming language. You can have like key 1, you can have it twice. And then your parser has to deal somehow with this, and in the end you have to deal somehow with this. All right. It does not assign any significance to the ordering of the name value pairs. Okay, so this is more close to an actual map, right? So there's key 1 value 1, key 2 value 2 is the same JSON as if you were to swap these ones. Okay, so these are all semantic considerations, and again JSON doesn't care about them, that may be defined by JSON processors or in specifications defining specific uses of JSON for data interchange. For example, if you have seen my video about the type-safe config library, what they did over there, they built a superset of JSON called HOCON, human optimized config object notation, and over there they actually attach semantics to some things. Okay, but JSON itself does not have anything like this. It's just syntax. So these are the objects. If you scroll down, as I already mentioned, most of this spec is pictures. Okay, arrays, see like 3 lines and you have a picture. Okay, so it's basically the same as objects, but you don't have key value pairs, you just have values. Instead of the curly braces, you use the rectangular parentheses. Okay, so an array structure is a pair of square bracket tokens surrounding 0 or more values, right? So you can have 0 values inside of an array. The values are separated by commas. The JSON syntax does not define any specific meaning to the ordering of the values. However, the JSON array structure is often used in situations where there is some semantics to the ordering, right? So again, JSON doesn't care about the ordering, right? But usually, typically, arrays are used for ordered things, right? All right, so now things are getting a bit more complicated. We're getting to numbers. A number is a sequence of decimal digits with no superflows leading 0. So you cannot have a leading 0. And by the way, the image for digits is a bit more complicated, right? So there are many ways you can construct it. All right. So it may have a preceding minus sign. So it might, it might go straight to something, or it might be a minus sign. Okay, it may have a fractional part prefixed by a decimal point, and a decimal point is always a dot, right? It doesn't care that I don't know, in German it would be a comma. In JSON it's always a dot or a period. Okay, it may have an exponent prefixed by e. This is this e notation, the small e or a capital E, and after the E, there might be a plus or a minus. And the digits are the code points. These are the 0 through 9, the typical Unicode 0 through 9 points, okay? So for example, let's try to construct some digits, right? So let's say it's going to be a negative, and then it's going to be, I don't know, a digit from 1 to 9. Let's say a -2, and it can be followed by other digits, right? So for example, 23, so -23. Then you might have a dot, right? 23.456 or something. You might after this have one of those e's. After that you might have a plus, and after that you might have another digit. These are the numbers, a bit more complicated than objects or arrays. Numeric values that cannot be represented as sequences of digits, such as infinity and NaN, are not permitted. Okay, so yeah, again, this is basically semantics. All right. Strings. Now, strings are the most complicated ones. In fact, this was the reason why before this video, I created an entire video about character encodings, about Unicode, about UTF-8, and all of these things. Okay, a string is a sequence of Unicode code points wrapped with quotation marks. Again, we're not in JavaScript. Single quotes are not allowed. It has to be quotes, which is also why if we scroll back up to objects say that a key must be a string, and therefore every key, not like in JavaScript, every key needs to be surrounded with quotes because it has to be a valid JSON string. Okay, so yeah, let's go. String. All code points may be placed within the quotation marks except for the code points that must be escaped. Pretty much every language has characters that needs to be escaped. So these ones are, for example, the quotation mark and the reverse solidus, which is the reverse backslash over here, and some control characters, which is 31 characters. They go from 00 to 1F, which is 31. There are two-character escape sequence representations of some characters. So some characters, which is a typical for most programming languages, they can be escaped without using the Unicode characters. They can be escaped by using two characters, right? So for example, if you wanted to represent a quotation mark, you would escape it with a backslash, right? So backslash quotation mark would be the quotation mark. Backslash backslash would be the backslash. And the typical one, backslash BF, and this is the line feed, this is the tabulation, and so on. So for example, a string containing only a single reverse solidus character, right? So a single reverse backslash may be represented as an actual double backslash. Okay. Any code point may be represented as a hexadecimal escape sequence. Escape sequence mean the typical backslash u and then the sequence. The meaning of such a hexadecimal number is determined by the specification. If the code point is in the basic multilingual plane, watch my previous video if you have no idea what this means, but basically it means all the typical characters in most languages, and not some fancy characters like an emoji. So these are these ones. Then it may be represented as a 6-character sequence, which is a reverse solidus, right? So reverse backslash, followed by the lowercase letter u, the typical, Unicode stuff, backslash u, followed by 4 hexadecimal digits that encode the code point, right? So for example, like this, it would be backslash u 0000, okay? Hexadecimal digits can be digits from 0 to 9, or the hexadecimal letters A through F. So typical hexadecimal notation. Or lowercase, right? So for example, a string containing only a single reverse solidus character, right? So a single backslash may be represented as this, backslash u 005c. If you Google this code point in Unicode, you're going to see that this is a backslash, okay? So the following 4 cases all produce the same results, right? So all of these are equivalent, okay? Capital F, small f, an actual front slash, or just a front slash. Okay, so to escape a code point that is not in the basic multilingual plane, the character may be represented as a 12-character sequence encoding the UTF-16 surrogate pair corresponding to the code point. Again, watch my previous video. I explain all of these very, very slowly. Okay, but basically, Unicode requires more than these 2 bytes to be represented, and therefore, similar in most languages, like in Java, you would do the same, right? So if the character does not fit into the basic multilingual plane, you would use these called UTF-16 surrogate pairs like this. All right, so let me just finish reading this for you. Okay, so for example, a string containing only the special G-clef character, which is like this, right? So notice that this is longer than the 4 character. So this is the 5th character, and therefore it doesn't fit into 2 bytes and doesn't fit into this basic multilingual plane. It may be represented as this, right? So this is 2 UTF-16 characters. However, whether a processor of JSON text interprets such a surrogate pair as a single code point or as an explicit surrogate pair is a semantic decision that is determined by the specific processor. So I wouldn't rely on that if I were you, but typically most of them do, because this is a very typical Unicode thing. And if you have seen my previous video, that you know that most of the Unicode characters, like the spaces for the characters, they're actually not filled out. We're currently using only less than 150,000 of the possible 1,050,000 values, and JSON over here actually allows you to use even the spaces, the places for which there is no assigned character yet. Okay, note that the JSON grammar permits code points for which Unicode does not currently provide character assignments. Okay, and again, the graphical representations for strings. Double quotation marks, it can be empty. Again, double quotation marks. Inside of the strings, you can do whatever you want, unless it's these characters that you need to escape with a backslash, or the backslash u, backslash u, and the 4 hexadecimal digits. And again, you can have this again, right? So this is a circle, and this is basically it. This is the entire JSON. Everything after that is the bibliography, and yeah, that's it. Let me point out a couple of other things since you are still here. If I click over here, this thing is a way of the notation, of this similar notation, but it's also a link. So if you open this in another browser, you're going to see some page with additional information, and one of those things is JSLint. So if you open that, this is a linter for JSON. So right, so you can, for example, go and you can create a JSON object over here. You can say, okay, so this is going to be key 1, and the value is going to be some number 1 to 3. Okay, and you can click on JSLint, and it's going to be valid. And if you have, for example, a comma in the number, it's going to say that it's invalid, because you need to have a dot for the numbers, like this, dot JSLint, like that. Now, since you're still here, let me just point out a couple of things about, related to JSON. The first one is JSON is a so-called semi-structured format. In this case, a format for information interchange. Semi-structured means that it's not a full-blown relational database with a bunch of rules for how tables talk to each other and stuff. But also, it's not just some random bytes, right? There's logic, there's syntax, there's no semantics, but at least there is a specification which explains a little bit how the data is structured, right? So it's a little bit structured, semi-structured. All right, guys, I'm sitting in front of a window and my camera actually overheated, so I needed to close the blinds a little bit, so it's going to be a little bit darker over here, but we're pretty much done with the video. All right, so where were we? Right, so since JSON is a standard, pretty much every language comes with a way to encode and decode JSON. In fact, because the JSON syntax is so simple, every language comes with multiple JSON parsers, right? So every language has a plethora to choose from. Another fact, and this is probably the most trivial fact, yet one of the most important ones, is that JSON is text, and therefore encoding is important. And even though the entire spec does not mention it, usually the way you encode Unicode characters is by using the format called UTF-8. And if you don't know about this, watch my previous video. I explained, the Unicode, all the character encodings, UTF-8, how all of this works. These UTF-16 surrogate pairs that we went through in the specs. Watch my previous video for that. The next thing that I want to mention is that the specification is not set in stone. Like everything else is software is soft. It needs to be able to change. The specification is constantly evolving. And for example, this JS linter itself, it is a little bit out of date. For example, for almost for the last 20 years, the valid JSON documents, and by the way, usually JSON is stored in .json files, and if you transfer them over the web, the MIME type is application/JSON. In any case, for the past 20 years, the valid JSON document would only allow you to have the global values in it as objects or arrays, right? So you couldn't go and just create a string over there, right? It would not be valid. However, we just went through the entire specification, and the specification does not mention any of that. Okay, so it turns out who do you trust, the specification or the linter? It turns out the specification is correct. I believe it happened last year in 2019. I'm recording this video in the beginning of 2020. Now these days you can have actually any kind of valid JSON value inside of a JSON document, not just an object and not just a string. In fact, we can actually go and try it out. We're inside of my browser, so I can do F12, which will open the the DevTools, and I can go into the console, okay, and let me increase the font a little bit like this. So what you can do over here, you can do JSON, JSON capital like this, .parse. All right, and you can give it some string of characters, right? So we're in JavaScript, so I can use single quotes for a string if I want to. Okay, and I'm doing this so that inside of it I can have a JSON, some JSON. Inside of it I'm going to have one string. Therefore, I'm going to do the double quotes, okay, and I'm going to say hello world. Okay, and I don't even need to press enter, but as you can see, it will actually work. Okay, so for example, it doesn't need to be a string. Okay, so this thing could be just, I don't know, just true, for example. Okay, or just false. Or also null, or also 10, right? So all of this is valid, and you actually don't need to go and create, a full-blown object, like for example, like this. Okay, you don't need to go and do key 1, and then the value is going to be, I don't know, true, and then you're gonna have a comma, and then you're gonna have key 2, and then you're gonna have false, right? So obviously this is still valid JSON, but you don't need to. You can go and create any value. Okay, and since we're already playing, let me also show you an array. Hold up. All right, like this. Let's create an array of numbers. So let's do 10, 20, 10, 20, 30. As I already mentioned, there is no localization for numbers or anything like that, right? So you cannot mix like commas and dots, right? So it's only dots. And also commas are not allowed, trailing commas are not allowed in arrays, right? So for example, if you have a comma over here, it's not gonna work. Same thing for objects over here. You cannot just end it with a comma. It's not gonna work. All right, things like this. Single quotes are not allowed in strings, as we have already seen. All right, what else? Right, XML is older than JSON, and there's this thing called AJAX, which is a pattern for asynchronous communication in JavaScript. So basically what it allows you to do, it allows you to load some data from the server without reloading the page. And since XML is older, AJAX stands for Asynchronous JavaScript and XML. there are some efforts to rename this to JSON because these days, even though XML is still widely used in some niche environments, on the web, not so much. On the web, JSON is the king. And so there are some efforts to rename this pattern to AJHJ, right? Asynchronous JavaScript and JSON, but these things take forever to catch on. So yeah, AJAX basically means asynchronous JavaScript and JSON. Another thing we need to talk about is the schema. XML is known to come with its schema, and schema is just meta information about the semantics of the data. JSON doesn't have anything like this. However, there seems to be a lot of interest in it, and therefore there are actually drafts and drafts for the specifications for the JSON schema. It's nothing major, basically key value pairs which describe the types. However, it's still not standardized, and only the future will tell if it will find mass adoption. All right, only a couple of things left. So JSON was originally intended as a clean subset of JavaScript, which means that you could take any object. Let's actually take this one, for example. Right, so I'm just literally copying it. I'm pasting it over here. So this is JSON, but I should be able to say dot key1. Right, and it seems like it's not working. Interesting. Maybe I should assign this to some variable first. Const JSON equals this, JSON.key1. True. Okay, so I don't know, maybe oh yeah, I think I know what I needed to do. I think I needed to surround this with another parens so that it's evaluated. Yeah, there we go. JavaScript is not my cup of tea. In any case, originally it was intended to be a subset of JavaScript. However, JSON actually allowed a couple of characters that JavaScript did not. However, all of this has been resolved now, I believe, actually also in the last year, in 2019. So these days, any JSON is actually a valid JavaScript object. Another thing that you should probably know, I imagine that you might be a front-end developer, and many front-end developers these days, they use Visual Studio Code. In fact, a lot of back-end developers also are using Visual Studio Code. I'm using it for Scala. So I'm going to jump in there and I'm going to show you that VS Code actually has a built-in linter for JSON files. So if you create a file, let's save it as some JSON. Okay, the Visual Studio Code is going to understand that this is going to be JSON, and the linter is built in. So if you do key1, value 1, all right, so let's, for example, JSON allows you to have duplicate keys, right? So if we do that, it will show you a warning. It might take a little bit of time, but it will show you that there is a duplicate object key. So let's fix it real quick. Let's, for example, also do key 3. All right, let's do 1, 2, 3, 4, 5, 6, 7. All right, and okay, hold on, I need to save it without formatting. Save without formatting, right? So this is an error. Like before, it was a warning, right? So if we do this, all right, again, let's save without formatting. Okay, so this was a warning because JSON allows it. Okay, but this one is actually an error, right? It says property expected. Okay, or over here if you forget a comma, okay, whatever. Let's do 0.345. Okay, if you forget a comma, if you go over here, it should say expected a comma. Okay, so the linter is built into Visual Studio Code. All right, let's fix that real quick. Another thing that you should know, that there is technically no standard on which casing to use in your keys. Most people use camel case, alphanumeric characters, right? So for example, this is camel case. However, in the wild, you might see people use dashes, or the snake case, or even the kebab case. The last thing that I will mention, and this part is actually important, we have gone through the spec, and there's nothing in the spec that helps you to resolve semantic issues related to, for example, something like versioning. Okay, it's all on you. In contrast to something like Google's protobufs, right? So protocol buffers, which is technically a binary format, but it's very, very similar to JSON. They actually come up with solutions to at least mitigate issues with versioning. Okay, however, versioning is always complicated. All right, I think I mentioned everything that I wanted to mention. Please don't be afraid in the future to read the specs. They're not always as scary as you might think. For now, as always, it's been Vlad, devinside.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on Patreon and thus watch my videos before everyone else. And most importantly, take care.